So this video, we're going to look at how to write about bonding and intermolecular forces in free response questions. On the AP test, there's going to be a lot of free response questions, or on the multiple choice, dealing with bonds and intermolecular forces. And so when we look at these types of problems, one of the things I want you to look at is first figure out what kinds of elements we have. Once we figure out the types of elements, so remember, if it's on the left side of the periodic table, this side here, it's metal, except for hydrogen. Hydrogen's a non-metal. If it's on this side of the periodic table, so there's an imaginary staircase that goes like this, right? So like this. Pretty much on this side here, non-metal. And then if it's resting on the staircase, it's a metalloid. So I've figured out the types of elements. If it's all metal, we're looking at metallic bonding. If it's all non-metal, then we're looking at covalent bonding. And this is where we start looking at, well, if I have covalent bonding, I definitely have molecules. And that's going to automatically tell me that I have something to do with intermolecular forces. Okay, so if I have covalent, that's going to be writing about intermolecular forces. If it's metal and non-metal, so if I have a combination of something metal, non-metal, that's ionic. And ionic, I don't have intermolecular forces. That's going to tell me, well, I have an ionic bond. And then we'll have to deal with the ions and how those pull apart. And if there's metalloids involved, which is on the staircase, so these are things like boron or silicon or common metalloids, sometimes you might have something such as a network covalent substance could result from a metalloid. So let's take a look at some examples here. I have this problem from 2004. This is a sample problem, and it says, using appropriate chemical principles, account for each of the following observations, talk about both substances. So let's go through each of these. A, at 25 Celsius, F2 is a gas, whereas I2 is a solid. So F2, I look and I say, well, what kind of elements are involved here? And F is on the periodic table right here. So that's a non-metal. I2, also a non-metal. Okay, so if I have all non-metals, that tells me that I have a covalent substance. And if I have a covalent substance, then I have molecules, which means I have to deal with intermolecular forces. Okay, so what am I going to do? When you have intermolecular forces, it's good to write about all three kinds of intermolecular forces. So I'm going to say, well, F2 and I2 are both covalent. So F2 and I2, both covalent bonding, and they have intermolecular forces. And then I usually make a table. Okay, so let's talk about the intermolecular forces again. Just to review, intermolecular forces are hydrogen bonding, which means I have an H bonded to F, O, or N. Okay, so you have to have H covalently bonded to F, O, or N. And then once you have that, that's going to tell me that there are hydrogen bonds there. Dipole deals with the symmetry and electronegativity of the molecules. So if I have something that's symmetric, that means that's not polar. But if it's something that's asymmetric, so if it's lopsided, then it could be polar. Okay, so if I have, we'll take a look at some examples later. And then London forces, everything has London forces if it's all nonmetals, but that deals with the total number of electrons. So the more electrons I have, the more polarizable it is. Okay, so let's make a table. I'm going to make F2, I2, and I'm going to write down H bonds, dipole, and London. And let's just go through them. Does F2 have H bonding? No. No. There's no hydrogen there. You cannot have H bonds if you don't have hydrogen. Okay, so neither of them have H bonds. Dipole. Well, F2 is shaped like this. It's F connected to an F, and I have some lone pairs here. I2, same thing. I connected to I, lone pairs. Are these symmetric or asymmetric? These are symmetric molecules. They're evenly shared. So there's no dipole. No dipole. So then let's look at London forces. And everything has London forces. Well, F2, if I look at my periodic table, F has 9 electrons. I has 53 electrons. So F2 has, 9 times 2 is 18 electrons. 53 times 2 is 106 electrons. So, do they have London forces? Yes. Does this have London forces? Yes. A lot of London forces. This has got so many more electrons than this one. Okay, so how I start writing this is they're both covalent. They both have intermolecular forces. Neither has H bonding. Okay, there's no H's, nor dipoles, forces. Then we can say they're symmetric. But they do have London forces. Both have London forces. And I2 has way more London forces than F2 does. So I2 has far more. And then write down about the electrons. F2 has only 18 electrons. I2 has 106 electrons. So 106 electrons, and we say this is more polarizable. So I2 with 106 electrons is more polarizable. I can't fit it on here. More polarizable than F2 with only 18 electrons. Okay? I'm sorry I fit that all in there, but that's how you want to attack these types of intermolecular force problems. If I have two things with intermolecular forces, compare them both, look at all three forces involved here.